minus 3. Alright, so first thing, let's determine the shape of the graph. So the coefficient, okay, the coefficient of x squared is a 1. Therefore, the value of a is greater than 0. So the graph is happy, so it will look like that. Okay? The graph is happy because the coefficient of x squared is a positive 1. Alright? So that's the shape. Right, then the next thing, let's find the y-intercept. Remember, you find the y-intercept when x is 0. So if you put x equal to 0, x equal, you get y equal to minus 3. So to find the y-intercept, if the quadratic function is in standard form, like that, you don't need to do any calculation. This is your y-intercept. There is no need of any calculation. You can get it by inspection. Okay, so this value here, that's the y-intercept. Right? Then the x-intercept, you have to solve a quadratic equation. Remember, you get the x-intercept by substituting y equal to 0. Okay, so where there is y here, we put 0. So if I do that, we get 0 equal to x squared minus 2x minus 3. Now, to solve this quadratic equation, first, you can try to factorize it. If it can be factorized, that would be the easiest way. Okay? You can also Right. So you can also use the quadratic formula to solve the quadratic equation. So in my case here, I'm going to factorize it. So it will be x minus 3 times x plus 1. So this is straightforward. It's a grade 9 quadratic equation. Okay? It's a grade 9 quadratic equation. Then you equate, you get x equal to 3 or x equal to minus 1. So those two are the x-intercepts. So this graph is going to pass through when x is 3, x is equal to minus 1. Alright? Are you following that? Now, the next thing is to determine the turning point. You need to know the coordinates of the turning point. Now, to find the coordinates of the turning point, I'm going to show you two ways. Two ways of doing it. Coordinates of turning point. I'm going to connect our knowledge of the turning point form and the standard form. I'm going to connect the two. So first, let's use the standard form itself. So method 1, to find the turning point, you have to know both methods because sometimes in a test or examination, one of the two will be the best for that specific question. So we have y equal to x squared minus 2x minus 3. So yesterday I told that the x value at the turning point, it's x equal to, let me use a different color to make this more clear. It's going to be x equal to minus b over 2a, right? The coefficient of x squared is 1, that's a. Coefficient of x is negative 2, that's our b. This c here, that we don't need it here, so b is negative 2, so it will be minus 2 over 2 times 1. This will give me 2 over 2. So x is going to be 1 at the turning point. Okay? The value of x at the turning point is going to be 1. Right? Now we need to find a y value which corresponds to this x value. to find that y value, we substitute this x here into that equation. Okay? So I'm going to do that here. So to carry on, I'll substitute that x value, so we'll get y equal to 1 squared minus 2 times 1 minus 3. This will give you 1 minus 2 minus 3, and you get 1 minus 5, and that will give you negative 4. Right? Therefore, the coordinates of the turning point, please, you don't write turning point equal to no. It is a point, you must write it in coordinate form. Turning point, x, what is x? It's 1. What is y? It's negative 4. So these are the coordinates of the turning point. Right? Then, equation of axis of symmetry. Right? This is extra information now, which you may need to know. Equation of line of symmetry or axis of symmetry. Right? That equation is going to be based on this value here. This equation here, x equal to 1, that's our equation of our line of symmetry. Right? The x value at the point, so at the turning point, gives you the x value along the line of symmetry. Right? So I now have all my information. Now I can sketch. Okay? Now I can sketch. Now, everything I have done here is extremely important before you start doing interpretation of the quadratic function. Right? So the next thing is for me to sketch. But I can also show you using method 2 to determine the turning point. So I showed you method 1. Let me show you method 2 before I sketch. Method 2 involves completing the square. Method 2 involves completing the square. So y is equal to x squared minus 2x minus 3. So since the coefficient of x squared is a 1, the coefficient of x squared is a 1. Therefore, we can easily complete the square. Right? Now, by completing the square, we are saying we need to add a term in front of that minus 2x such that we create a perfect square trinomial. Right? So to do that, we first have to find half of the coefficient of x there. It's minus 2. What is half of minus 2? Negative 1. So this becomes x squared minus 2x. Then we add half of the coefficient. Let me emphasize this. Half of the coefficient of x there, it's going to be minus 1. So we add the square of that minus 1. We also subtract it. Right? Then we subtract that 3. Like that. Remember, I did this recently when I was teaching the quadratic pattern. Okay? I explained this part here when I was doing the quadratic pattern recently. Okay? When you are completing the square, you first have to make sure that the coefficient of the first term, right, that x squared term, you have to make sure that it's equal to 1. That's number 1. Number 2, you need to determine half of the coefficient of the second term, which is half of the coefficient of x. Then, to create the perfect square trinomial, you need to add half of that coefficient, you need to add the square of half of that coefficient, you also subtract it. What is the result here? It's a 0. It's a 0. I explained that almost like 2 weeks ago when I was teaching the quadratic pattern. The same concept of completing the square under quadratic pattern is also required when you're doing the quadratic function. It's a very important technique in maths. Right? Then, from here you get y equal to x squared minus 2x plus 1 minus 1 minus 3. Now, this is now a perfect square trinomial. Remember, I told that there are 2 types of perfect square trinomials. The 2 are, okay, let me write them in general form. Okay? So we have x squared plus 2xy plus y squared. If you factorize that, you always get x plus y squared. Always. Okay? Another one is x squared minus 2xy plus y squared. This will be equal to x minus y all squared. So in our situation here, since we have a minus here, we are dealing with number 2. Okay? So if I call this one here number 1, that will be number 2. Right? So from here, you get y equal to x minus 1 squared minus 4. Okay? Now, when you compare the general equation of the turning point form, remember, the general equation is y equal to a times x plus p squared plus q. I'm sure you can see here that since there's a minus 1 here, there's a positive p. It means at the turning point x is going to be equal to 1. Right? The value of p is negative 1. But x at the turning point is positive 1. Okay? Be very careful. The p is not positive. P is negative, but x is positive. Right? The q value is very straightforward. That's minus 4. This is a positive q, which is what I got here. This is the q value. This is the, okay, that's not p. That's x. That 1 there. The p value is equal to negative 1. Because the equation of the equation at the x of symmetry is x equal to minus p. Therefore, if p is negative, then it means the value of x is going to be positive. Make sure you are aware of this. Alright? Any questions? So from here now, if I move from here, I'm sure you can see that from there, you can say our turning point, x is 1, y is negative 4. Then you are done. So you can decide which way you prefer. Okay? The one which you understand better, but it is always wise for you to know both ways. Well, some questions require either of the two methods. Are you following? Okay. So now let me sketch. Okay, so can you stop that? Right, let's start with the X intercepts. So we have X equal to 3, so the X equal to minus, let me just check properly. X equal to 3 and X equal to minus 1. Okay, so I'll go to X equal to 3, which is here, X equal to minus 1, that's there. And then we have the Y-intercept, it's at minus 3, which is here. Okay, then our turning point is at x equal to 1 and y equal to 4. So it will be here. Right? Now remember, our shape is the minimum turning point. So when I sketch it, I'll start from the top, going down. Something like that. Okay. Because we are complaining, let me redo it. It's supposed to be there. So you see, because I wasn't seeing, I need to be very careful how I draw it. Because we have got people who rush to complain. It's not that easy, but I will try. You think if you draw something like this in a test, I'll penalize you. I won't. Because I'm not looking at perfection. This is not drawn to a specific accuracy. It's freehand. Okay, so this is not a bad shape. Right? So we have got that. Then we label the graph y equal to x squared minus 2x minus 3. Now, let's go further now and analyze this. Okay? Let's write down the domain. So, the domain, right? The domain is going to be x is an element of real numbers. We are starting from minus infinity up to positive infinity. For all your quadratic functions, the domain is from minus infinity up to positive infinity. Remember, this can also be written as x is an element. We are starting from minus infinity up to positive infinity, like that. Right? Then the range. Now, the range, first you must identify whether the graph has a minimum turning point or not, or a maximum. Since there's a minimum turning point, it means we have a minimum value here, which is what? Negative 4. Negative 4 is our minimum. So our range is going to be y is greater than or equal to minus 4. But y is an element of real numbers. Okay? We can also write that range using the brackets. So that will be y is an element. We are starting from minus 4. The minus 4 is included. That's why I'm putting the square bracket. Up to positive infinity. Like that. You can also write this using inequality signs. Minus 4 is less than or equal to y is less than positive infinity.
So we need to write the plus sign.
Well, if you don't write it, it's fine. Okay. You following? So I'm giving you, I gave you 3 ways to write in the range there. 3 notations. So you can decide which one you prefer. Generally, I prefer the first one. Right? So we can also have other questions here, like for what values of x is the function increasing? For what values of x is the function decreasing? Like how we did for the trigonometric graphs. Right? Those type of questions, they can also be tested here. Are you following? Right. Let's write for what values it is increasing. The graph is increasing if it has a positive gradient, or if the x values are also increasing. So it is increasing from here towards the left. Therefore, if x is greater than 1, the graph is increasing. Okay? To the right of this point here, the graph is increasing. To the left, it is decreasing. All right? Any question? Yes?
So if they say here, for what values of x is the graph increasing one, just like how is that how you put it?
Yes. The graph is increasing, the gradient is positive. So the gradient is positive from this point going to the right. So all the values to the right, they are greater than what? 1.
This is the same graph.
We are talking about the quadratic function. Let's not talk about the tree graph. All right. Any question? Okay, if you don't have a question, then let's move on to the next example. What was the next equation? What was the next equation?
Negative 2x squared plus 8x plus 8.
Wait, it's y equal to negative 2
X squared
negative 2x squared. Yes?
plus 8x
Plus 8x
plus 10
plus 10. Alright. So first thing, let's determine our shape quickly. So our value of a there is negative. So the graph is going to have a maximum turning point. Right? Then The y-intercept, remember we can find this by substituting x equal to 0 or by inspection. So our y-intercept is this value here, positive 10. So our y-intercept is y equal to 10. Then the x-intercept, okay, x-intercept, y will be 0, right? The x-intercept. Right? So here you can use the quadratic equation, or the quadratic formula complete the factorization. I'm going to factorize, so I'll divide every term by -2. Can you stop that, please? I don't want to hear any sound here which is not about work. Stop it. 8x over -2 plus 10 divided by -2. So this will be 0 equal to x squared minus 4x minus 5. So I have simplified it. Now I can factorize. So that will be x minus 5 times x plus 1. Right? So my x-intercept will be x equal to 5 or x equal to -1. Right? Now be aware that I have simplified the equation from here to there so that I can factorize to make it easier. But your original equation is this. This is the original equation. Right? So let me find the coordinate of the turning point. Right? Coordinate of the turning point. I'm just going to use method 1 because of time. Coordinate of turning point. So that would be y equal to minus 2x squared, right? Plus 8x plus 10. So x is equal to minus 3 over 2a, right? Remember, this is the a value. The b value is positive 8. We are not worried about the c. Okay? So b is positive 8 and a is negative 2. So we'll get x equal to minus 8 over minus 4. So that would be x equal to 2, yes?
So I'm just trying to understand these equations and understand all the way now. So basically, they'll give you an equation, a quadratic equation, like that one you have there, and then they'll tell you to either give that coordinates at the turning point or give
No.
it. How is that?
The question will say, sketch the function, sketch the graph of the function, y equal to minus 2x squared plus 8x plus 10, indicating all the critical points like x-intercept, y-intercept, and turning point. Alright, so x equal to 2. Now we need to get the y value at the turning point. So y is equal to minus 2 times 2 squared plus 8 times 2 plus 10. So this will give me minus 8 plus 16 plus 10. So 26 minus 8 will give you 18. Therefore, the coordinates of the turning point are going to be 2 and 18. Alright? Equation of axis of symmetry. Right? Your equation of your symmetry is going to be x equal to 2. Now, be aware that this value x equal to 2 is also the value at the axis of symmetry. So that's straightforward. Right? Now, we just have to sketch.
So it's not a bit of the question and everything. But can you get a Y value in this equation?
Okay, so that's what you're supposed to have. Then we can write the domain, right? Our domain obviously is X is an element of real numbers, the range, right? Now to determine the range, if the graph has got a maximum turning point like this, you go to the turning point, which is there. The value of Y is that. So that 18 is the maximum value of Y. So the minimum is down there, minus what? Infinity. So when you write, you can write as Y is less than or equal to 18, but Y is an element of real numbers. Okay? You can also write this as Y is an element. We are starting from minus infinity up to positive 18, put square bracket. Okay? Please be aware that when you are writing the range or the domain, you start with the minimum first, not the maximum. I have seen learners starting with the maximum instead of the minimum. I saw it even in the control test. That's not how I taught you. When you're writing the range of the domain, you start with the minimum first. Or if you want to use the inequality signs, it will be minus infinity is less than y, y is less than or equal to 18, because the 18 has to be included. Right? So this is what I expect. Now, if you can manage to sketch the graph, then the interpretation will become easier for you. First, be a master of sketching. If you can't sketch, then you won't be able to interpret. If you can't sketch, you will struggle to interpret. All right? So for today,